It is.
Well,
Yes.
It's not neither, is it?
No, that's right. That's right. So it's a bit funny, isn't it?
They're not complements.
If that's exactly right. If Z was your universal set, then these two are not complements because they're both missing 0, right? So 0 would be, yeah, it's outside. Yeah. 0 always, see, you would be in this camp, obviously. 0 is always ruining things. But anyhow. What would the next set be? We actually have a name for it, and you know what the name is. When numbers aren't whole, what do we call them? We call them rational numbers. Now, then you think, I'll put an R. No, we're not going to put an R. We'll save the R. We're not even going to call F for fractions because there are numbers that are in this set I'm going to tell you about that aren't fractions. I'm going to put a Q like this. A Q. So we have extra lines so that you don't think it's a number Q. Just like by convention, you know, if you're in a diagram, right, like this, here's some geometry, right? By convention, just so that we have a similar set of rules and everything's not just random, we usually use capital letters for vertices. And we usually use lowercase letters for sides. And we usually use Greek letters for angles, right? And that's just so, usually, not all the time, but usually. In the same way, yeah. Okay, we usually use them. Now, Q is the set of rational numbers. Does anyone have any guesses as to why it's a Q? It's not that hard actually. This one doesn't appeal to another language like this one. Q for. Now I think this is about rational numbers, fractions, kind of, division, right? Quotient. That's right. So this is kind of a reference to that operation. Okay? Rational numbers. Okay, now we're missing some numbers, right? I've got all the whole numbers. I've got some negatives in here as well. Now I can have a half, a third, a quarter, and so on. Okay? But there are lots of numbers we're missing. Okay, so I can say irrational numbers. Now, the thing is, even the name itself, irrational numbers, right? It tells you that this set here, this set is defined in terms of another set. Irrational means not rational. So the most common sense way to write this would be to say it's the complement of Q. Okay? Now obviously, you've got to be a little careful, don't you? Because we've seen before that the meaning of a complement changes based on what your universal set is. Okay, so you have to be careful with that, but this is one's useful.
Imaginary.
Okay, now, where do we go from here? There are some numbers missing. There are some numbers missing from here, okay? And they're actually very famous numbers. Some of the most famous numbers in all of mathematics. In fact, they're kind of like the superstars, the ones that you learned there. They're special. We don't even have, numerals for them. We go 1, 2, 3, and so on. These guys are so special. We don't even use our alphabet. We go out of our alphabet for these usually. Think about it. Think back to like year 7. One of the most important numbers you learnt about. And it was special. And it didn't have a number to it. Pi, right? Pi. Pi is a Greek letter, right? What is it? It's 3.141592653 blah 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 blah. Okay? We'll get to this in a second. Now, here's the important thing, right? Pi, we often use 22/7 as an abbreviation for it, right? It's close. I think it gets you to it's 3.142. It might be 3.14. Is it wrong?
No, it's 3.14.
Yeah, it's something else, right? So it's within 1/3% of pi. That's not bad, That's quite accurate. Like if you think of 1/3% of anything, that's not very much error. Okay? So this guy, for such a simple fraction, not bad.
But then again, 3 is within a couple of percent.
It's within about 5%. Because if 3 is like, 100% equals 3. Anyway. The point is though, pi is not one of these. Pi is definitely not one of these. Okay? So we need to expand out. And this is where our R comes in. R. I alluded to this before. These guys are the real numbers. The real numbers. Okay? Real. So these guys are really important. when we talk about real numbers, I honestly didn't intend that. When we talk about universal sets, like what are usually the numbers we're interested in? Okay, this by far is the most common universal set in all of mathematics, really. It kind of is the giant, he's the main one. You can go outside him, as we'll see in a second, but we almost never do, okay? Real numbers. How do you define these? These are easy to define. These are easy to define in terms of the previous branches, right? So for example, how would you define rational numbers in terms of integers?
Not integers.
Is 2 a rational number?
Yes.
Yeah.
It is. It's 2 over 1.
Yes.
How would
that can be
I'm going to ask you this
expressed
question.
in a fraction where it's not
Good. Okay, so it's what happens when you, not even talking about fractions, because it's not really a fraction, is it? A rational number is what happens when you divide 2 integers. That's it. That's the simplest definition I can come up with. Okay. If you divide any of these, you'll get one of these. What are these? Keep in mind, you got to have some really weirdo kinds of numbers in here, right? This is a big family. What are these numbers?
Numbers except the imaginary numbers.
Okay, but what does that mean? That doesn't tell me what this is.
You can't
What's
define
this? Yeah.
it using itself.
Would you like add up all the other ones? Like say like
It's these and these and these. Yeah, that's tricky. That's tricky because like, what if you miss one? I'll talk about that later on. Here's what I'm going to give you. I think this is the best definition. Okay, the real numbers are all the numbers that if you square them, right? If you square them, then the result will be greater than or equal to 0. Like so, if x was a real number, right? Then x squared will be greater than or equal to 0. Those are the real numbers. Every real number, even the weirdos like pi, you square them, they'll be 0 or they'll be bigger than 0. Can you see that that's true of every number that I've written here? Does that make sense? Integers, natural numbers, you square them, no problems.
How about 0?
Negatives, you square them, no problems. 0,
Yeah.
you square it, you still get 0, no problems, okay? Fractions here, you can square them, no big deal. Weird numbers like this, and I'll get to those guys, they're a whole branch of maths on their own. You can square them, all good, yeah. Okay, so this is using our set notation. Okay. This means x is an element of, or belongs to, or is a part of the real number set. X is in R. X is in the real numbers. Or if you like, you can just say if x is real.
So, do we have to do the double line? Because I never do the double line.
You should do the double line. It's really easy, by the way. You just do one line, right? And then you do another line, and then you do the R around it. That's all.
That just means
So we use that for U to make it universal. We use it for M, Z, Q, and R to make it refer to these particular sets. Okay. One last set for you. It's a C. Anyone know what it stands for? We've talked about this. We spent a whole lesson on them almost. It really actually stands for what it's.
Counting.
C for, no, we did counting. C for complex.
Oh.
Now, not to be confused with imaginary numbers. What complex numbers includes is, well, look at how we define real numbers. Look how we define real numbers. Real numbers are the numbers where you square them and you'll get something that's greater than or equal to 0. Complex numbers includes all of the numbers in all of these, but it's got some extra bonuses. It's got numbers that when you square them, you don't end up here, right? You can square them, you can get negatives, you can get other weird stuff on different axes, 2-dimensional numbers and so on. Okay. So if you were to draw a Venn diagram for these, right? Basically every time you go up, you're expanding out a level. You'll have kind of these concentric circles. Here are the natural numbers, right? Including the natural numbers but some extra ones, the integers, right? Including the integers but some other ones, the rational numbers, right? Including the rational numbers but some other ones, the real numbers, and the complex numbers come outside here, okay? And that's pretty much all of the sets that we really need to worry about.